We are working with vectors, and we're going to look at, I'm going to use the homework questions as much as I can because they're kind of set up for me. They're nice and visual. But let's start with a simple question like, how do you find the components of a vector joining 2 points? And this is kind of a review of last time. So let's suppose I have a point 1, 2, and I have another point here 3, 5. So if I use my square paper, actually, that would probably work better. So you got your X and Y axes. And you pick the point 1, 2, which would be here. And then you pick 1, 2, 3, 1, 2, 3, 4, 5, you pick here. And you want the vector from P to Q. If you had a diagram, you just say 2 to the right and 3 up. So the vector PQ would be 2 to the right and 3 up. And that's fine as long as it's easy to plot. But it does get a little bit messy if the numbers were really big or really awkward. You know, like negative 253 and I don't know, negative 162, right? You wouldn't really want to plot them, right? So there must be another way in which you can do that. And there is. Essentially, if you want to find a vector P to Q, you can do this. Call this guy x1, y1. Call this guy x2, y2. And so all you need to do is second take away first, second y coordinate take away the first. And in this case, it'd be negative 1 take away that guy, comma 62 take away that guy. And that would be 1, negative 1 add 2, that would be 1. And that would be 9. So there is a way to calculate the vector joining one point to another, and it's simply just that one. I describe this formula as second take away first, second take away first. It's easier in my brain to do it that way. And that's just one of the many things that you might get with vectors. So let's show you some visual ones as well. Are you looking at question 5? Okay. Now, if you want to do the vector from P to Q, let me check something. Oh, good. Right. If you want to do the vector from P to Q, couldn't you just say 1, 2, 3, 4 to the right, 1, 2, 3, 4 up? And in here, if you click on the vector thing, do you see the funny little square brackety guys? You can go 1, comma, not 1, comma, what was that? 4, 4, 4, 4. And that should be it. Yeah. There is, however, another way to write a vector. It uses the vector I and j. You remember I was 1 in the x direction and j was 1 in the y direction. Now, if you wanted to write your answer that way, instead of 4, 4, you would say 4. You go down to vectors and you pick that guy. You see how it's a bold eye? That's the vector I. And then add 4, the vector j. And that would be correct if you just hit the j on your keyboard. That's obviously wrong. If you hit the j on your keyboard and just the letter I on your keyboard, doesn't that look like 4i plus 4j? But if you do that in your WebAssign homework, it's going to say that you're wrong because that's just a letter I, right? Like a variable. You need to make sure that if you're going to do the ij stuff, that you do the vector I and the vector j. The vector j. If you want to see what the vector I looks like, it's 1 in the x direction. So it's basically that guy, right? And that's how it works. Now, in this one here, can you go along and down? So what would that be? 1, 2, 3, 4, 5, and -3. So if I wanted to do this one, it would be, I like this notation, so I would go 5 along and 3 down. And that would be my answer. I like that notation. Can we do question 7 using the formula that I showed you a minute ago, and question 8 the same way? Here we're given an initial starting point. So that's a point 5,6, which I'm pretty sure is there. And then you have to do the vector 3,4. So let's see what that would look like. So you'd start here and you'd go 1, 2, 3 along and 1, 2, 3, 4. Well, it ain't that one. Start here, go 1, 2, 3, 4 along, not that one. Start here, 1, 2, 3 along, 1, 2, 3, 4. So that's the one where you'd start here and go 3 along and 4 up. And then it asks you for a thing called the terminal point. So they're actually looking for this guy's here, coordinates, right? And that guy there is what, 8, 10. So you go 8, 10. Right. If I, and I have done it myself, did that. Oh, you want the coordinates of the terminal point? It's 8, 10. Have you noticed I've put the brackets inside as 8, 10? Do you know WebAssign is not that bright? It's going to tell you you're wrong. So you may well, and I do know that when I marked some of your stuff in your onlines, that you got 0 points for a question, and all you really did was you put brackets where you didn't need to, right? So always be on the lookout. If it gives you a bracket, then you don't need to. Do you know those funny little ziggy triangle brackets? Those ones? Sometimes they give you that, so all you need to do is put in 5, 1, right? So watch what they give you or what they don't give you when you're doing your answers. Here's an example of sketch a vector. Let that one go. Now, this guy is in I and J notation. This question is dead easy, but I'm going to do it anyway. It's 1 in the X and 9 in the Y. So you just go to here and you do 1 in the X. So 1I plus 9J, which that's pretty much easy to do. Here is a deliberate mistake. Even if the WebAssign says it's not, it really is a mistake. What is wrong with that answer?
Could you just put 12i?
Yes, and that's what you really should put in. Would you agree that if you're doing algebra and the answer is 12x plus 0, don't you just write 12x? Nobody writes plus zeros if you don't need it. And if the answer was 0x, wouldn't you just write 0? You wouldn't actually put the x in. So we have some conventions like that. I want to see if I can make this a little bit bigger. So, evidently not. Okay, let's stop this for a minute. We're kind of back to where we were last week, so that's a good place. So here are some questions that involve us doing the algebra vectors again. So suppose I give you a vector u, and it's called 6, 7. So this is basically questions like 13 and 14 and so on. I tell you a second vector v, and it's 2, 3. Then we can do a number of calculations involving these two. For instance, you might be asked to do that one. Well, that's 2 times vector u, take away 3 times the vector v. If you want to find 2 times a vector, just double its components. And if you want to find 3 times a vector, treble the components. And then if you want to add or subtract vectors, 12 take away 6 and 14 take away 9. Intuitively, isn't adding and subtracting and multiplying vectors kind of obvious, right? If you want to add two vectors, you add the x's, you add the y's. Are we good with that question? Right. The only difference is, and it's a very minor one, but let's talk about it anyway. U is the vector I plus j, and V is the vector I take away j. When we write vectors on paper, we put the little arrow above it so everybody knows it's a vector. And you're just asked to do the same basic calculation. So I'm only picking one. 2u take away 4v. That becomes 2 lots of this vector take away 4 lots of this vector. And so that becomes 2i plus 2j. Well, I could distribute that. So if I did, it would be negative 4i plus 4j, a bit like the distributive law, and then collect like terms. Negative 2i plus 6j. Are we comfortable with that? You can do it with, me personally, I like this notation better than the I and j. My i's and j's start looking very similar to each other, especially when I do it quickly. And I end up adding things I should never add together because of that. I'm less likely to screw up when I do this notation. So we are good.
Professor, on the
Yes.
questions you were doing, when you said we could do the I and J form and also the like
brackety form, yeah.
Yeah. The question said component form, and then the ones where you're doing the I and J said you had to do it in that form. So I was wondering on the quiz, because you go through and like mark it yourself sometimes.
If you write one when you should have written the other, I'll give you a point. Don't worry about that, because it's the same vector. It's just, you know, the notation, and that's not a biggie. So yeah, if you're doing an online quiz and you're doing the final exam, which actually the final exam will be mostly on paper, I'll be able to see your work and you'll be fine. Right. Here's a guy from last week. We're talking about the magnitude of a vector. Basically, its length and how you calculate it. So let me give you a vector u, and it's going to be 2 take away 3, right? That guy. The notation for the magnitude looks like an absolute value symbol, right? It's 2 vertical lines. And the formula for calculating the magnitude is this guy squared plus this guy squared. 4 add 9 gets you square root of 13. And that's basically it. You will see in other places that they use that notation instead. It's basically not just one set of vertical lines, it's a double set. And that also means magnitude. So in case you go looking in YouTube, you know, for some examples, some extra work, and you think, oh, what the heck's that? That's just the same as this guy, right? Depends on what textbook. WebAssign uses that, so that's the one I'm going to use. Okay. Now, let's pick a guy and do some examples of magnitude. Let's have a vector u equals 6, negative 10. And have a vector v, which is going to be 1, negative 2. And I would like to know the magnitude of u and the magnitude of 2u take away 3v. Right? Pretty good examples of that type of calculation. This one is pretty easy. It's just 6 squared plus negative 10 squared, and that would be the square root of 136. And this one would take a bit more work. So I'd have to find two of these guys. So I'd probably do it more like this. I'd do my working at the side. So 2u's would be 2 of this guy. Take away 3 of this guy. And that would be 12, negative 20. Take away 3, negative 6. And that would 12 take away that gets me 9. And that guy, take away that's like adding it. So I basically get that fella. And now I could calculate it. So it'd be 9 squared plus 14 squared. Too much work and I don't want to risk it. So bring the calculator into play. 9 squared plus essentially it is 14 squared. 277. So let me ask you a question. I could do that calculation, couldn't I? I could find out the magnitude of 2u, and I could find out the magnitude of the vector 3v, and then I could subtract them. Is that answer going to be the same number? That's your question. Yes or no? Do you think this and this should be the same answer? What's your gut feeling?
I feel like it won't.
You're correct, it won't. So in general, combining two vectors together and finding their length is different than finding their length separately and then combining the answer. Right. So if you wanted to see it as a kind of mathematical formula, it would look something like this. There is only one exception to that rule. The only time this would equal that would be if these two vectors were parallel to each other. So you're basically just doing a u and then adding a v to it. Well, wouldn't that be the same length? Right. That would be the only exception. Yes.
So at the top where we started subtracting 2u and 3v,
Okay.
we don't take the minus sign between like the end of vector 2 and then minus 3. We don't like multiply to get like negative 3.
You could. I just choose to do the negative at the end. But if you want to do that negative 3, make sure that you put a plus here to compensate.
Okay.
But if you said negative 3 plus 6, well, you remember to put a plus negative 3 plus 6, and that way you'll get the right answer. And
Okay.
that's the reason, that's kind of the reason I don't do that, is because I'm careless. So I know if I leave the negative to the end, I'm more likely to subtract it correctly. But yes, you could do it that way and there'd be nothing wrong with it if you chose to. Are we okay with magnitudes, or do you want to see more magnitudes?
Can we do one more?
Sure. Let's pick a vector. Oh, let's do the ij's. Let's do 2i plus a j, and the vector v can be 3i minus 2j's. And let's do the magnitude of that guy. So I would first add them together. And another reason I don't like this notation is I'm lazy, and it's a lot more writing, isn't it, when it's an I and j? You have to just write a whole load of stuff down. Now I can combine them. 2 and 3 gets me 5i, and 1 and that gets me negative 1j. Are we comfortable about u plus v being 5i minus 1j? So the magnitude of it would be the square root of 5 squared plus -1 squared, which is the square root of 26. Okay, let's do the other two then. Let's find the magnitude separately and add the answer. Right, if you want the magnitude of this fella, it's the square root of 2 squared plus 1 squared, which is the square root of 5. And if you want this fella, it's going to be 3 squared plus -2 squared, which is 9 and 4 is 13. Have I convinced you that that answer is not the same as that one? And that's a truism, that typically is not going to be the same as that. Are we good? So square roots, little hiccups. I don't think hiccups is the right word, but style points. If your answer is the square root of 17, it's still the square root of 17. If your answer was the square root of 9, would you agree that you should write 3? That makes sense. You would call it 3, right? And if your answer was the square root of 8, shouldn't you call it 2 square root of 2? Right? You remember simplifying square roots. So always get into the habit of tidying up the answer if it's possible. Would you agree there's nothing you can do to that answer? That's as good. And there's nothing I can do to that. So these answers are fine. But occasionally you might get a number that comes out as a nice value, or at least can be simplified. And that's a good habit to do that. Good math to do that. Are we good with these now? Good enough? Right. Let's move on to how to find a vector, the components of a vector, when you are told information such as this. No, I'll do the paper. I don't need any particular one. Yep, forgot about that one. I'll throw it away. You can tell it's coming to the end of the quarter. That's the only pens I've got that work now. 2 greens, 2 red, and 1 black that's dying on me. So who knows what tomorrow is going to bring if I don't get some pens soon. So anyway, back to the.
I only have 2 pencils that are working. All the others are broken or have disappeared.
Right, so it's getting to the end of the quarter for everybody, right? You know, it's going to be bad when you have to find your little sister, beat her up and steal her pens off her, if you have a little sister. Okay. So we're going to look at a different way to give people information about a vector. This vector is going to start at the origin. And I'm going to tell you the magnitude of the vector, and it's going to be 5. And I'm also going to tell you the angle that it makes with the x-axis, and it's going to be 30 degrees. So if I try to draw this vector, it would look something like this. Can you imagine that's 30 degrees? And from there to there was 1, 2, 3, 4, 5, right? And there is your vector v, right? So can you describe a vector kind of like polar, isn't it? You know, distance from the origin, the angle it makes, right? And if you gave someone this information, angle and magnitude, you should be able to write down what the vector is in its component form, right? So that's its x component. This number here is called its y component. And we're going to use a formula that you have met before. It's just written in a slightly different form. The x component, that's this guy, is the magnitude of v, the cosine of the angle. And the y component is the magnitude of v, the sine of the angle. Now, I said that is a formula that you've seen before. It just looks a little different. If I went and said to you, x is r cos theta and y is r sine theta, does that ring any bells? Agree? Isn't that like the r, and isn't this definitely the theta? So it's really the same information. It's written in this format because that tends to be the way that the numbers are given. They don't call this guy R, they call it the magnitude of the vector, right? In this case, it's 5. So in the story that I have in front of me then, the X component is going to be 5 times the cosine of 30 degrees. And the Y component is going to be 5 times the sine of 30 degrees. And we will work on the assumption, and it's a good assumption to work on, that if they don't say to 2 decimal places, that means they want exact values, which means you're going to have to use this guy. If you find 30 degrees, it's this angle here. Which one of these two numbers then is the cosine of 30 degrees? Is it the X or the Y?
The X.
Okay, and so that's √3 upon 2. So there is your X component. And would you agree that the other one's a half? So I guess if I made that look pretty, it'd be 5 halves. So this vector, right, has an X component of this number and a Y component of that. So you would say vector V is 5√3 upon 2, 5 halves. Are you comfortable with how I transferred this information into the usual way that you write vectors, right? They're X and Y components. Try another one. Suppose I have my X and Y again. Suppose I have a vector, call it V again. Oh, darn it, space. Okay, I can call that V. And I'll have another one down here that I'm going to call W. And V has 45 degrees. So for vector V, its magnitude is 2 and its angle is 45 degrees. And then for this guy here, the one that I'm going to call W, this angle in here is 60 degrees. And the magnitude of W is 3. And the angle is not 60 degrees. What angle do we use to represent the vector W? It's not 60 degrees because we don't measure angles going this way, do we? The standard way is to do it that way, right? Anti-clockwise. So what angle do you really write in here? I've seen the moves,
300.
the lips moving. So 300 degrees, right? 60 shy of a whole circle, right? 60 shy of 360. Now, these guys can then be turned into the vector. So V is going to be the magnitude of V times the cosine of 45 degrees, and the magnitude of V times the sine of 45 degrees. And that's going to be 2 times √2 upon 2, and 2 times also √2 upon 2. You can get them from here. And that comes out as a very neat looking answer, that one. You comfortable about that one? Now, the other one I'm calling W. It's going to be the magnitude of W times the cosine of 300 degrees. The magnitude of W times the sine of 300 degrees. That's going to be 3 times, and if I find 300 degrees, which is here, the cosine is a half, and the sine is negative √3 upon 2. So I guess I wanted to tidy that up a little bit. It would be 3 halves minus 3 √3 upon 2. and that would be W. So far, so good. Now, the next thing I'm going to do is not very pretty, but you could be asked to do it. You could be asked to find the resultant force. That just means what you get when you add them. Resultant force, yeah. What's the result of the two forces working together? And it's going to be this fella plus this fella. And oops. And I said the answer's not pretty, which it isn't. But it's still the answer. So that would be the resultant force. Now, in this question, I didn't mention, nor would I want to, that the answer is to 4 decimal places or so on. So if they don't mention accuracy like that, you need to do exact values. Even, and they will very often in these kind of situations, even when the answer looks decidedly ugly, it's what they want. Do you want to see any more examples of a vector written where you're told the magnitude and direction and are asked to convert it to its component form? Or are we good with that kind of question? Don't want you to see any more? Feel good? You want to see another one? Tell me that.
I'm just wondering what we're finding right now.
What this is?
Yeah.
Right. If you took this vector here, right, let's do a baby version of it because I don't have enough room. If you took the vector v and then you added on to it the vector w, so you would do this nose to tail thing, this ugly guy at the bottom that you can't see anymore would be that green vector, what you would get if you added the two together. Now, if you can imagine, and they like stories like this, can you imagine there's a big ship here and there's 2 tugboats? One of them's pulling it this way and the other one is pulling it that way. If you add those 2 together, the answer would probably look like a vector going this way, right? That would be the direction that the boat would be getting pulled, right? The resultant direction, right? And so you can think of adding vectors together is very similar to adding forces together, right? You got a force pulling this way and another different force pulling that way. What would the combined effect of those 2 forces be? That's what adding the vectors does, right? It's a way of combining 2 distinct forces together. That was a good question. I like that question. We got any other questions? Or do you want to see another one, as I said? Okay. Then our next topic is the other way around. I'm going to do the vector, although you don't need to, but to make my life easy at least, I'm going to do this vector starting at the origin. And the vector v is going to be 4, -2. So that would be 1, 2, 3, 4 along and 2 down. That's roughly what v would look like. Great. But what we are going to do is we are going to find the magnitude of v and the angle that it makes with the x-axis. So we've just been told these and find that. Now we're switching it. I'm going to tell you that and you're going to find these. Okay. Now one of them's pretty easy. Would you agree getting the magnitude of a vector? We know how to do that, but we're going to do it again because we kind of need it for the second part. The magnitude of a vector is the square root of 4 squared, that guy, it's a square root of 20. And can anybody tell me what that simplifies down to? Because it does simplify.
2 square root 5.
Right? So you call it correct. You call it that and you get 2 square root 5. So that's just good math, right? Now, there is a formula for finding the missing angle. Can you remember this formula from Polar and from other places? Remember that guy? Well, I want you to think of that as the x component and the y component. So if you want to find theta, isn't it going to be the inverse tan? If I rewrite this slightly differently, isn't it going to be the inverse tan of y over x? So it's going to be the inverse tan of -2 over 4. And that becomes the inverse tan of -0.5. Now, unless you are extremely lucky, as you have, I'm looking at a question over here, you're going to have to round this off to, let's say, 1 decimal place. So you don't need to worry about getting exact answers, which means you don't need to worry about the unit circle either. They want this answer in degrees, so I'm going to my calculator. I'm going to make sure that I'm in degrees, which I wasn't, so I'm glad I checked. And then I'm simply just going to go inverse tan. But do not be surprised if the answer you get is not the answer you were hoping to see. Do you see that this answer is a negative number? It's -26.6 degrees, which kind of makes sense. Would you agree? -26.6 degrees would mean that, wouldn't it? But that is not theta. That's not to be written down with the answer that the calculator gives you. We always measure theta between 0 and 360, and it's always measured anti-clockwise from the x-axis, right? What could I do to this number to get the one that I do want?
Add
Add
360.
360.
Right, so since that's in front of me, I'm just going to go plus 360, and 333, what's that become? 333.4 degrees. So can you imagine that you might get a little hiccup, right? The angle that you get from the calculator may be the one you want, and that's great. When that happens, you say great. But when it doesn't happen, don't you have to fix it, right? So you have to know, you know, how to fix it. Let's see if I can find another one that's going to cause problems. Let's have an angle up here, and let's make this angle 111 degrees. Okay, and the magnitude of this vector can be 2, right? Oh, I take that back. I'm doing the wrong question. Let me put a guy that's over there. That's what I wanted. I was kind of doing the answer without the question. So I want a guy here, and his coordinates are -2, 5, right? And that's my vector v. And the magnitude is -2 squared plus 5 squared. So you'd be given the vector, it would be written like this originally. And then I drew the picture from it. So this guy is the square root of 29. Now, if I want to get theta, it's the inverse tangent of the y over the x. It's the inverse tan of 5 over that guy. And that becomes the inverse tan of what? -2.5. So I've got my calculator handy, and I'm going to go inverse tan of -2.5, and I'm going to get an even weirder answer. Let's say to just the nearest whole number, it's -68. The angle I want is this angle here. If you wanted to imagine where -68 would be, wouldn't it be starting here and going the wrong way, 68 degrees? It would actually look like that. You notice that the calculator gives you an answer, but it ain't always the guy you need. Isn't the guy I want in the second quadrant? Isn't that pointing to somebody in the fourth quadrant? So it's not the right place. How do I get from here to here? I know that angle. How do I get that angle?
Do you add 180?
I would. And if you take 68 and basically add a straight line work, which is 180, you will get to where you need to be. I was darn close, right? 112. And there you go. You got an angle and you've got a magnitude. And I've showed you the two horrible ones where nothing works out right. Great. Do you want to see another one of these components and finding the angle and the magnitude? Are you good? We're good. I got a thumbs up. We're good. Okay. Moving on then. Oh, darn it, space. Don't get it. Here's the story. That's the ground. Here is a box. And a guy is pulling that box with a force of 20 pounds. So if you're doing that in physics, don't you have those little chain things with the little needle, and as you pull it, it tells you how much force you're using? So it's 20 pounds. And he is pulling on this guy, and he's pulling it at an angle of, what number? 30 degrees. So this is basically a version of question 23. We are being asked a guy called the horizontal component of the vector v. So we'll call this vector v. And the vertical component. If you have a vector v and you write it down like this, that's called the x component, right? And that's called the y component. It also has another name. It's called the horizontal component and the vertical component. So basically, they're just asking you for x and y, aren't they? Now, if you want to get the x component, also called the horizontal one, the formula was the magnitude of v times the cosine of the angle. And if you want to find the y component, which is also called the vertical component, it's the magnitude of v sine of theta. So in this case, HC, the horizontal component, will be 20 pounds. Because if they tell you the force, they are essentially telling you the magnitude. So it's 20 times the cosine of 30 degrees, and the vertical component is 20 times the sine of 30 degrees. And in this question, they don't mention accuracy, so that means we need exact values. So this guy is going to be 20 times root 3 upon 2 and 20 times a half. This comes out to be 10, and this ends up being 10 root 3. And there's your question. And if you want to write it down as a vector, it would look like that.
And you said so the force is what we're using as the magnitude. Why is
Yes.
that?
Basically, if you imagine someone pulling something in a certain direction, the amount that they pull it by, the force, can be thought of as the length of that vector. So the length is a way of representing how big the force is. So a force of 10 pounds would be a little line, right? A force of 200 would be a huge line, but wouldn't they all be pointing in 30 degrees? So magnitude of a vector can represent the force that you're pulling at, which is one of the main situations that they've got. Now this next one is a version of question 24. And this time we are doing a jet flying. So I'm actually going to do north. And this jet is flying at what angle? It's flying at 10 degrees north, 10 degrees east. So it's basically flying that away, with this angle in here is 10 degrees. And this jet is traveling at a speed of 600 miles an hour. So in the context of this question, the magnitude of the vector can represent its speed. So you can use the length of a vector, its magnitude, to be the force that you're pulling. You can use it to be the speed that you're going, right? They can be used in, the magnitude can represent different things. Now, we are being asked again to find out what that would look like as a vector, right? And then we'll talk about what else is going on here. Right, that angle is not theta. If I add in the ground, which is the x-axis, isn't the angle theta the angle the vector makes with the x-axis, not the angle that it makes with the y-axis? So in this case, wouldn't the angle be 80 degrees? Does that make sense? Now, you can calculate the x and the y, guys, in any way that you want. If I wanted to, for instance, do the horizontal, I would call that the x component. It would just be the magnitude times the cosine of 80 degrees. And if I wanted to do the vertical, which I would call the y component, wouldn't it be 600 times the sine of 80 degrees? And in this case, I'm pretty sure you would be doing to 2 decimal places, say. So if I go here, clear it, 600 times the cosine of 80 is about 104.119. And then if I do 600 times the sine of 80 degrees, I'd be looking at, that doesn't look right. Let me try that again. Let me try the first one. 600 times the cosine of 80. Okay, that's good. And then 600 times the sine of 80. That's much nicer. So it's 509.88. So if you tell me the angle that it makes, either with the ground or with the vertical, I can tell you what its components are. So what we then do is we put these things together. And we essentially get a story where we have two vectors working with each other. So in this story, which is question 25, we have two banks of a river, and there's a guy here, and he's swimming at 2 miles an hour. And we have a current going this way at 3 miles per hour. And we're being asked to find the true velocity And what else? And the true velocity as a vector. Oh, assuming the I and j, right? Okay. Anything else? No, that's it. So the true velocity, they want you to do it using the vectors I and j, which is fine. I can live with that. So I got a guy swimming this way. There's my little guy swimming, right? And the current going that way. And I know that this is east, and that is, in this case, south. If I was using common sense, would you agree that the swimmer is probably going to be swimming in that direction? Would that seem reasonable? Okay. Now, in this story, since that is straight east and that is straight south, I should be able to find vectors for each of these. So let's do the guy. There we go. Isn't he going 2 east, 0 up and down? Great. What about the river, the current? How would you describe 3 units going down the way? What vector would do that job?
0, -3.
Great. Are you all comfortable about why that's a -3 in this story? Right. So I guess I should put names on them because squiggly guy and thingy is not a good name. Let's call this guy U, right? And let's call this guy V. Then if you're thinking, what would the combined effect be? Well, it's called the resultant force. Wouldn't the resultant force just be you add the 2 vectors together? Right? Swim, current. And if you add these 2 together, I can do that without even writing them down. Would you agree it's that guy? Still with me? Seem reasonable? Okay. Now they ask for this thing called true velocity. If the length of the vectors is basically the velocity, then won't the length of this guy be his true velocity? So I just need to find the magnitude of this vector. So it's going to be the square root of 2 squared plus -3 squared, which I believe is the square root of 13. Are we comfortable with that? Now I'll turn that into a decimal because I think it might come out quite interesting.
Would it be miles per hour as well?
Yes, it will be. It's about 3.6 miles per hour. So the magnitude is 3.6 miles per hour. Now, if you think about it, he's only swimming at 2 miles an hour. But how come if if he had some kind of speedometer on him while he was swimming, he'd be saying, hey, I'm going at 3.6 miles an hour. How can that happen? I mean, in the physics of it, what's happening here?
He's
Well-
partially swimming with the current, so he's going faster.
Yeah, isn't the current helping him go south faster? Right, it's kind of, aircraft don't they talk about headwinds and tailwinds and things like crosswinds? That's basically the wind blowing in a certain direction, right? If you've got a headwind and you're an aircraft, imagine that's an aircraft, you've got wind going like this. And this is, the aircraft. If you're trying to go at 300 miles an hour, but the wind is blowing that way, won't your net result be you go quite slow, right? Won't you slow down? Right? If the air was perfectly calm, you'd be traveling 300, but the wind is against you. On the other hand, and I'm kind of expert on this, can't you get a tailwind? So if there was no wind blowing, the aircraft is, doing its 300 mile an hour. But if the wind is behind you, doesn't it give you an extra 50 miles per hour? When I eventually get back home to Scotland, there is a wind system called the Gulf Stream, which you may have heard of. which means that if you fly from Seattle to London, Heathrow, it takes you a different amount of time going than it does when you're coming back. Because when you're going, the Gulf Stream, I can't remember which way around it is now. When you're going from Seattle to Heathrow, the wind is speeding you up, right? It's giving you a little shove, so you go faster. But when you're coming back, it slows you down. And I don't think it's a lot, but it's something like 30 minutes. So if you look at an aircraft, you say, why does it take 9 hours and 20 going, but only 8 hours and 50 coming back? It's to do with the Gulf Stream. And I don't know, ships in the olden days used to take advantage of that. If you were in a sailing ship, wouldn't you try and use the winds that were at your back, even if that involved traveling south 200 miles an hour to get a good westerly wind, you know? So it wasn't that uncommon for people to use winds in the same way. And I think we've got time for one more. No, we don't. Right, tomorrow we are going to do some other objects moving in space and finding what their magnitude is, what their velocity would be. And I don't have time, but if I did want to, couldn't I also find that angle? Wouldn't I just do the inverse tan of that divided by that and then get negative 20 degrees or whatever it is, and then we could measure its angle. Remember to put your last name down for attendance, and bye-bye from now. And I'll hang about for any questions that you might have.
Thank you. Bye.
Bye-bye.
I had one question from the vector homework.
Sure. Hold on a second. I'll get myself organized for you. Okay. Is it something I need to look for, or can you read it out to me or whatever?
You should probably look for it. It's not. I don't think it's anything that simple. It's.
Oh, okay.
It's
I
just
gotcha.
kind of weird. I don't know.
Weird's a good description. I have used that term myself in some of these questions. Right now I'm just trying. Whoa, that's not good. Got a weird window here. Give me a few seconds to shrink some windows up. Right, I've got this guy. What section is it in again?
I think it's 9.1.
Okay, score view 9.1, working with vectors. Let's find your name, E. Okay.
It's just the second one. I know they're like wanting me to define what it means, but I just don't get it.
Okay, I got you. Question 2.
Mm-hmm.
Oh, darn it in flipping space. I'm really getting annoyed at myself. I clicked on something that I didn't mean to click on, and now I'm having issues finding it. Yeah, I got it. Okay. Gotcha. Okay. Question 2. Right. If I'm looking at the right one, it says consider the following. Assume that each point lies on a grid. Is that the question?
Yes, it is.
Right, and so you draw the picture and blah, blah, blah. And it says the length of the vector A, you got that right. That's good. Magnitude root 2, you got that. It then goes on and says, if we know the length L is the magnitude of W and the direction theta of the vector W, we can express the vector W as, okay. We did that formula today, and it was called magnitude of vector cos theta, magnitude of vector sine theta. Remember that guy?
Yeah.
Right. All you're going to do is, instead of magnitude, you're going to put L cos theta and L sine theta.
Okay. I guess I maybe should have taken a second look at it before I asked for help again, because I was looking at this before class today, and I was like, what is going on?
Okay, you just double check it. It's a capital L as well. So it's really pernickety. You can't use a little L when it needs to be a capital.
Okay, let me check it.
Sure.
Okay, and then I also have one from the parametric equations.
Okay, I'll go hunting for that one. And here we go. What question number?
It's number 7, I
4.
think, or yeah,
Is it-
number 4.
Yeah,
And we
I've
did
got
this one earlier,
right.
and it's not what it wanted, or maybe I did it wrong or misunderstood.
No, it is the right answer, but it's not the one they wanted. They want y squared equals x cubed. It's just not being very, it's not clever enough to realize that you can write an answer down in more than one way. So it's
Oh,
y squared equals x cubed, which is totally fine because that's what your equation is. In fact, that's probably what your equation was before we made it y equals.
yeah, and so if I would have done that, the y equals on a test, would I get full
You get all
points
the
for that?
points. So if you were doing
Okay.
it, I would look at that and say, yeah, she's got the right answer, no problem.
Okay. This is kind of a random question, but so
Mhm.
I've been borrowing a graphing calculator from my school, and I have got like a grant thing, so I want to buy one, but I don't know like what is the best one to get because I want to keep continuing with math, but I don't know what graphing
For
calculator
us,
I want.
as our math class, the TI-84.
TI-84.
Yeah,
Okay.
I'll put a picture of what it looks like, just so if you see one, you'll know it's the one I'm talking about. The one I've got is a little bit old. The newer ones have color, which makes them nicer. So, but it's a TI-84. That's
Okay.
the one I use. It's got all the features like, you know, we've used it occasionally, like the graphing and so on. You can do that.
Okay, so you can do all the things I'll need to do in math with that.
Yeah, you have to be
Perfect.
careful because some students get money and they use a calculator that's called a calculator that does algebraic manipulation. That is not a good one to get because you're not allowed to use them in exams because you can actually, if you had such a calculator, they do all sorts of cool things, but not good for math because they will solve equations for you even if you don't know how to. And all sorts of unscrupulous things can be done with them. And okay, you could probably, nobody would know if you were doing your homework, but then if you're not learning how to do it algebraically, you won't know how to do it when you get an exam because we don't let you use them.
Okay, so this is the one I'm currently using. Oh, sorry.
No, I guess I was just wanted to ask if there are TI-84s that have that ability. Like are there like versions of the TI-84 that like
no,
you
if it's called TI-84, you're fine.
Okay.
If they want to do something, they're called a totally different letter combination.
Okay.
Right. What were you showing me there again?
Oh, it's just it's like a TI-84, but it's like a CE plus or something. It's the one I'm borrowing, so
Is that one got color in it?
Like on the window?
Yes.
I think it might. Yeah.
And if it is, then you're just getting the one I showed you right now. That one I've gotten is literally about 8 years old.
Okay.
So you know, so in 8 years they've made the screen nicer and they've made it colorful and little things that make your life easy, but nothing that's serious. It still does what the other one does. And you're okay.
And then quick last thing, for my attendance, I was missing one day, I think in either week 3 or 4. And I haven't missed class yet, so I don't know if that could be fixed or if I need to like go back and find myself in the videos or something.
I should check that. Grace, I'm 142. Let's find out which one that was. Attendance. So last E. You're right. Well, week 3 didn't have a day off. Oh, I think all I've done for week 3 is said 3 out of 4 when it was 3 out of 3. Did you get 100% attendance?
Yeah. I think I got a 3 out of 4, and I thought that I had been there all.
Let me. Yeah, I'm wondering if I can't count. No.
Or I guess mine was week 4.
Yours is week 4. I have a week 4 discrepancy, right? So let me fix that one. Right, that's better. Right, all the other guys. You know, get some kind of weird color scheme thing going on here. Just a few seconds more and I fix it. Right, that's that one fixed. I have a week 6 that said you had 2 days here instead of 3.
For week 6.
Yes. Let me check.
Um,
I'm trying to scroll. That's not good for me. Were you here week 6? Did you miss any day at all? I know you said earlier you haven't missed any,
No.
so I'm assuming that you never missed one in that day either. Then
No, I could not miss this class. I don't understand. I can't teach myself math.
okay, then I agree. Okay, we something's not right here. Shooting space. What's not right? Oh, there we go. Now it's fixed. Okay, done.
Okay,
You're
thank
good.
you. I appreciate it.
No problem. Harmon, you got a question?
Yeah.
What you got?
The moment you started talking about the I and J form,
Yes.
I ended up having to leave the computer for a second.
Okay.
So could we go over that just one last time?
Right. The I vector is 1 in the x direction. The j vector is 1 in the y direction. So you can write vectors down like this, or you can write them equivalently, there's a hard word to say, like that. So when they talk about ij form, they want the vector written with i's and j's, and when they want component form, they want it written like that.
What's the use of this form?
This form here,
Yeah.
I don't know. I don't like it, but that isn't a good reason.
It kind of
just
just, I mean, it just kind of seems pointless, I guess. I mean, unless you wanted to put it into an equation base, I guess that would make sense.
if you deal with them, they do behave much more like algebra. In other words, if I took a vector 3i plus 4j, right, say 2 of them, and I took away 3 of some other vector written in the same way, then combining them would look much more like algebra. You would distribute them.
Yeah.
And then you could collect like terms. And for some people, dealing with vectors in that format works better in their brain because they're used to collecting and distributing and multiplying and adding and so on. And when it's in this format, it just makes more sense to them. Maybe that's a made-up reason, but how about that as a reason?
Okay, yeah, because I was like thinking, like, don't we do that exact same thing in like vector form anyway? Because
Yes, we do.
have to.
I'm lazy. That's easier to write than these.
Yeah.
And also I'm careless. And so my eyes turn into j's. And when I scan, I add this guy to that guy instead of this guy to that guy and all sorts of mistakes. So for me, I don't like the notation, but that is for me.
Yeah.
There are uses of it. In Calc 3, you'll do things called cross products. And when you do cross products, I and J notation is actually quite convenient for some questions. Or at least it allows you to prove things that are easier than it might be to do it by writing the vectors in this way.
Yeah.
Is there any reasoning for choosing I and J? They look so similar.
I know. No, it's just I, J. Actually, if you do Calc 3, they do I, J, and K because there's 3-dimensional vectors as well.
Okay.
But there's no reason for it. It's just convention. I, J, and K is what everybody calls them, so we all call them that. But you're right, I and J do not look good.
No.
At least the way I write, they don't look.
Me too.
They don't look different enough. So in quite a few questions, they're going to be written with I's and J's. I would turn them into these guys. Do whatever it is you need to do. And then at the end, if they want an I and a J, then you know how to write it in. But everything in between is all in this format here. And that's just safer for me.
Awesome. Thank you. I'll see
Okay.
you tomorrow.
See you tomorrow. Any other questions, Armin, or are we good?
Yeah. Help with, because I kind of forget how to simplify square roots.
Square roots, okay. So if you take a square root, like say 40, what you need to do is find two numbers that multiply together that give you 40. But one of the numbers, let's make it the first one, must be a square number. And a square number is things like 4, 9, 16, 25, right? And so on. So when I look at this one, I say, oh, 4 times 10, right? So you take the number and you break it as two things multiplied, in my case, 4 times 10. You're then are allowed to split the square root into two separate square roots. The algebra says that this is allowed. And the square root of 4 gets you 2. So there's your answer.
Okay, so it's just using square root properties to sort of like separate it out and make it look
Right.
the same.
And the trick is to try and pick the biggest square number that you can get, right? But both numbers must be whole numbers. You can't do 9 times 3 halves, right? Not allowed, right? It has to be 9 times 2 or 9 times 7, right?
Okay.
So the biggest square number you can get, and boom, you're done. There are a lot of questions that can't be simplified. So if I was doing the square root of 17, I would do, well, it's either 4 times something or it's 9 times something. That ain't going to happen. That one's good. On the other hand, if I was doing the square root of 30, I would say it's 4 times something, it's 9 times something. 30 is a bad choice, actually. Let's make it
32?
Yeah, let's make it 32. So 4 times something, 9 times something, 16 times something. And I would say, hey, wait a minute, 16 times 2.
Yeah.
And might not need this line for root 2. Now, could I have done that one? Yeah, but that one wouldn't have been as good as this one. You always pick the biggest square you can get away with. In this case, 16.
Okay.
Are we good?
I think so.
Okay. Office hours are at 10 o'clock. So if you have something before class that pops up, just drop in.
Alrighty. Thank you.
Okay. You're welcome. Bye-bye for now.